Okay, so now it's 2 o'clock sharp. Okay, so I think we can proceed to our chapter 2. Okay, so in our previous chapter 1 and tutorial 1, I already tried to introduce to you the guideline or the framework that normally we can refer in order to initiate, okay, a chemical plant design project. So if let's say you are remember, if let's say you are still remember, okay, in our lecture 1, okay, basically I already introduced 2 different framework to you. Okay, among these 2 framework, okay, the first one that suggested or introduced by Mr. Peter is actually the common framework that actually normally we refer in order to initiate the chemical plant design project. Okay, and also in the framework, okay, there are a lot of different stages, okay, we need to proceed. And under each stage, okay, we need to consider a lot of different consideration and also the element and also the task that we need to achieve before we move on to the subsequent stage. Okay, so basically this is actually what we learned and I try to explain in our chapter 1 and also tutorial 1. Okay, so in our chapter 2 today, yes, we will still proceed, okay, to the process design. But in our today lecture, chapter 2, okay, so if you are still remember, this is actually the framework that introduced by Peter, okay, similar to the flow chart that I explained in our lecture 1 lecture notes, okay. But in our chapter 2 today, we will focus more on the second step and also the third step, okay, that involved in the framework that we introduced by Mr. Peter, okay. So meaning that in our chapter 2 later, I will try to guide you actually what are the tasks and actually what we need to do under the stage number 2 and stage number 3 in the framework that introduced by Mr. Peter in the framework that we learned in chapter 1. Okay. Okay. So, okay. So this is the outline, okay? These are the elements or tasks or sections that we are going to learn, okay? So as I told you just now, okay, for our today lecture, chapter 2, we will try to focus and learn the second and the third stage inside the framework that introduced by Mr. Peter, okay? So if let's say we want to try to complete the task or we want to complete the second stage in the framework they introduced by Mr. Peter, first we need to know how to collect and develop a design database. Okay, in our chapter 1, okay, I already tried to share with you some of the idea what are the database that actually we want to establish and we want to collect. But in our today chapter, we will try to go in further, okay, to see, okay, where is the platform or website or even reference book that actually we can refer in order to collect the relevant design data, okay? And also, once we collect all the relevant data and information, then we need to proceed to the next section we call process creation. Okay, process creation. Once we already create a process, then only we can proceed to design a process. Okay, so of course, when we design a process, of course, we can also produce a process flow diagram or short form we call PFD at the same time. And the PFD is actually very important because later we will try to proceed to try to design the unit operation, for example, the mechanical design or even the P&ID, okay, piping and instrumentation diagram, okay, all of them, okay, are actually developed based on the PFD that we have here, okay. This one is P&ID, okay. Once we already come up with a complete P&ID, already finalize the P&ID, then only we can proceed to prepare the piping layout and also the plant layout. So meaning that for our today chapter, we will try to zoom in and focus, okay, into the task or the small element, small component that actually we need to complete under the stage number 2 and stage number 3 in the framework that introduced by Mr. Peter. Okay, so as I told you, okay, last week, okay, so if let's say, okay, you want to try to come up with a chemical plant design, okay, the first objective, the first step that you must achieve is you need to identify what is the product that you want to produce, okay, what is the objective that actually you want to achieve, and based on the expected product or the objective, then only you can proceed, okay, or start with the chemical plant design project. Okay, so the design, okay, depends on the product or the task that you are going to solve. Okay, the chemical plant design can be a totally a new design. Okay, start from zero. So means that you want to try to design a new chemical plant, and so far there is no any relevant literature has been reported by other researcher or engineer so far. Okay, you want to come up with a new thing. Okay, this is the first method. Or the second method, you can try to refer to the previous chemical plant, okay, and try to modify the existing chemical plant that we have in order to come up with another new chemical plant in order to achieve your objective. Okay, so meaning that once you already identify the task that you are going to solve or the product that you are going to produce, okay, up to you, okay, and also depends on your luck, okay. Sometimes, okay, the product is totally a new product, then no choice, you need to come up with your own new design. Why? Because it's a new product. Then so far there is no relevant chemical plant or the technology can be applied or modified in order to produce a new product that you want to produce. So in that case, no choice. You need to come up with a totally a new, okay, design. And if let's say you manage to come up with a new design, then of course the novelty of the chemical plant design is high, then maybe you can proceed to apply intellectual property to try to protect your design. Okay? But if let's say now the product that actually you want to produce is actually a very common product, and so far in the market or even in the scientific journal article, there are a lot of different method or technology have been reported, okay, on the production of the similar product. Then in that case, you can proceed to try to do some literature review in order to collect the relevant data and try to modify the existing design or plan in order to proceed to produce your product. Okay. So as I told you just now, either you come up with a totally new design or maybe you modify the existing design. Okay. So no matter which method you apply, I'm sure, okay, you will start to encounter a lot of different challenges. And some more in order to resolve or overcome these challenges, you need to make your decision. Okay. For example, if let's say now you already selected a technology to produce your product, then the next question or the next challenge that you are going to solve is what are the unit operations that you are going to install or construct in your chemical plant? How are you going to connect them together? Which unit operation should come first? If let's say you rearrange the sequence, then later at the end, okay, the performance of the chemical plant will become totally different. Then, okay, it may also influence the quality or purity of the product that you are going to produce. So that's why when you make the decision to overcome the challenges, okay, there are a lot of different factors and consideration you need to consider, okay, in order to make sure at the end you manage to come up with a chemical plant design that can actually produce and achieve your target. Okay, and all the decisions that you are going to make it can actually give a huge impact, okay, to the performance of the resulting chemical plant, okay, and also it can determine, yes, okay, it can also determine, okay, the quality of the product that you produce and how good is the quality and how it can actually try to beat down your competitor in the market, okay. Okay, so remember, okay, as I told you just now, chemical plant design is actually very challenging, okay, and normally, okay, uh, the design process is really straightforward. So meaning that you are going to encounter a lot of different challenges, and you need to try to work with each other, okay, work together with your the team member, okay, in order to come up with a chemical plant design. So as I told just now, okay, either you come up with a totally new design or maybe you modify the existing chemical plant, okay, no matter which method you are going to apply, okay, you need to always bear in mind that make sure the chemical plant design that you come out at the end, okay, can make profit, okay, because the reason why we want to construct and set up a chemical plant, money. So that's why this is the first priority. At the same time, we also need to make sure the chemical plant can actually be operated safely, okay, can be controlled properly, okay, and the most important is, okay, you also need to make sure the design that you come out, it can also address most of the environmental concern, okay, that we want to achieve, okay, in the market or in the society. Okay, so far, any question before we proceed to try to share with you the task that you are going to do in the stage 2 in the framework that introduced by Mr. Peter? Edmund, so far, do you have any question before we proceed?
No question, sir.
No, okay, thank you. Okay, thanks for your feedback. Okay, so now we proceed. Okay, so now we proceed. Okay, this is the framework that introduced by Mr. Peter. Okay, in our lecture 1, I try to introduce to you, okay, all the stages that involve in the framework here. And remember, normally, okay, the framework, okay, that introduced by Peter is actually the main reference that we normally refer to in order to come up with a chemical plant design, okay, because the stages or the flow or the sequence is actually easier to be followed. Okay, so stage number 1, okay, first we need to identify the product that we want to produce or the objective that actually we want to achieve. This one is actually stage number 1. So if let's say we already identify the product we want to achieve, we already identify the product we want to produce and also the objective that we want to complete and achieve, then we can move on to stage number 2. Stage number 2 in the framework that introduced by Mr. Peter is known as create one or more potential solution to meet this need. So means that now we already confirmed the product we want to produce. Then now is the time we want to try to do some literature review. Means that we are going to try to refer to the previous journal article, reference book, or even the pattern that share, okay, by the publisher, okay, or how to produce the product that actually you want to produce. So meaning that under the stage number 2 here, you will try to gather the relevant information to see actually how many relevant technology or how many process that actually currently is using by the industry or market to produce the product that actually you want to produce. Okay, not only to identify the possible process pathway, how to produce your product, but under each process pathway, because they are going to use different raw material. So that's why we also need to try to compile and gather the information of all these raw material that you are going to use under each process pathway. Basically, this is covered in stage number 2 here. Okay, so if let's say now I give you an example. Now let's say, Uma, what is the product that actually you want to produce? If let's say now you are the investor, you want to construct a chemical plant.
I don't know.
You don't know what you prefer, what you want to produce. If let's say you are a boss. Okay, Kuma don't want to answer me. Never mind. Let me answer my question. Okay, let's say now you want to produce Panadol. Okay, Kuma, I want to unfriend you, Panadol. Okay, let's say I want to produce Panadol. Okay, I think, Kuma, do you know what is Panadol?
Yes, of course I know what is Panadol.
Okay, thank you. Okay, let's say now you want to produce a Panadol. Okay, Panadol, cannot, okay? So if let's say now you want to produce Panadol, okay, first you need to start, to try to do some literature review to see how many different technology or the reaction pathway or the process pathway that is currently using by the industry to produce Panadol. So meaning that, the first, what we need to do is we need to identify all the possible technology or process that actually we can apply to produce the Panadol or our product here. Okay, at least you must get at least 2 different processes. Then only later you can try to compare each other in order to select the best one. If let's say you manage to get 3 different processes, then later you can compare these 3 processes in order to select the best process pathway to proceed to your chemical plant design. So of course, since the different processes here, they will use the different unit operation. That means they are going to use different equipment to produce a Panadol. Why? Because the technology and process they are going to use and involve is different. And also the raw material that they are going to use to produce the Panadol depends on the process here. They also need different raw material. So that's why for each of the identified possible reaction or process pathway, all of them will come up with different scope of the project since they involve different equipment, different raw material. Okay, and since they are going to deal with different processes and also the raw material, some of this raw material can be very toxic. So that's why you need to know later how to handle this toxic raw material. But this one will be discussed further later in our subsequent step. So we continue. Just now, I told you already, different processes, different pathway, they have different scope of the project. And also since they try to involve different processes, then later in the identified process pathway here, later you will also encounter different design problem, due to the different technology and processes that you are going to use in the identified process or technology here. Since the unit operation equipment that you are going to use is totally different, the raw material that you are going to use is different, and also the intermediate, they might produce in the process here is also different, and also the technology that you are going to use is also different. So, later the data that you need to collect for all the identified reaction or process pathway here will also be totally different. So as I told you just now, first, you need to identify all the possible pathway that can produce your final product. Okay. Okay. Once you already identify the possible reaction pathway, okay, the possible reaction pathway, then you can start to proceed to carry out the literature review. Okay, the literature review, okay, actually there are a lot of data actually you need to collect and compile. The first one is actually the properties of the raw material that you are going to use. Why? Because later you are going to handle this raw material in the chemical plant that you are going to design. And some more, you also need to ensure all the operator and engineer, they can actually, how to say, work safely in the chemical plant that you are going to construct. So that's why, if possible, we need to try to avoid the use of the toxic raw material if is possible. Okay. And as I told you just now, okay, because when you want to try to start with the chemical plant design, okay, I told you already, either you come up with your own new design, or maybe you try to refer to the existing chemical plant in order to do some modification based on the existing plant in order to produce your product. If let's say you are actually trying to modify the existing chemical plant, then at the same time you can also try to get the flow sheet. Flow sheet, that means the process flow diagram that is currently using by the industry or maybe the academic to produce the relevant product. And based on the process flow diagram, okay, later we can also identify all the equipment or the unit operation that required in the process that you are going to apply. So this one is also considered as part of our literature review, okay, to collect the relevant information before we start ready to, okay, come up with our own design. Okay, and all this information, they are actually very important and useful, okay, to support our design and our decision later. Okay, and also, okay, so if let's say you still remember in our chemical engineering thermodynamic and simulation, we learn how to do the simulation for the chemical plant. Okay, so if let's say when you do the literature review, okay, you can get the relevant data or information, okay, which is related to the simulation, okay, of the product that you are going to produce. You can also try to keep it, okay, for your future reference to support your design later. Okay. Okay. So now you may ask, sir, how to collect the relevant data? Is there any reference book or platform we can try to refer in order to collect the relevant data or information or do our literature review? Okay, here are the online references. Okay, so here are the online platform or maybe the website that actually you can try to get the relevant data, as for example the properties of the chemical or raw material that you are going to handle, okay, or the latest technology that are invented by the scientists, or even the existing chemical plant that currently using by the industry to produce a product that you want to produce. Okay, all of them can actually be extracted from the scientific website or platform here. So beside that, okay, so here are also some of the reference book that actually as a chemical engineer, we can refer to in order to design our chemical plant or unit operation. Among the handbook or among the reference book here, this one, the first one, is actually the most important handbook that we normally refer to as a chemical engineer. Okay, this one is Perry Chemical Engineer Handbook. And inside the handbook here, actually there are a lot of the fundamental properties of the raw material, a lot of relevant data. Okay, actually we can try to get from the first handbook, Perry Chemical Engineer Handbooks here. Or even some of the vapor liquid equilibrium, okay, that can also be retrieved or extracted from the handbook here. So that's why this one is actually can be considered as the Bible, okay, as a chemical engineer. Why? Because, okay, most of the cases, if let's say we have any problem and we want to try to refer the handbook, okay, or reference book, and normally the Paris Chemical Engineer Handbook is the first handbook that we will try to refer to. Okay. If let's say we really cannot get the relevant data from the Paris handbook here, then only we try to go to other handbook to compile and collect the relevant data. Okay. For example, if let's say now you want to design the unit operation, let's say you want to design the distillation column or other equipment, okay, you have problem, then maybe you can also refer to the unit operation handbook here. Okay, if let's say you have problem with the process, then you can refer to the handbook that is related to the process, chemical process. Okay, and one more things, okay, today homework, later after you go home, okay, make sure you do the homework, try to download the Paris Chemical Engineer Handbook. Okay, you can try to get it from either from our university library, or maybe you can try to download from other relevant website. Okay, try to download the Paris Handbook, okay, the latest version, and keep a copy in your computer, because later maybe in the assignment of this module, or maybe in your final year design project in your final year, okay, maybe you need to refer to the handbook here in order to support your design. Okay, so beside that, okay, if let's say you have any problem, okay, related to the hazard, okay, of the chemical or raw material that you are going to use, okay, you can also refer to the handbook here. Or maybe you have problem, okay, you're not sure actually how are you going to treat the waste that you are going to generate, then you can also refer to the handbook here. Okay, so here in the lecture notes, actually I try to provide you some of the reference book that actually you can try to refer in order to get the relevant data or even knowledge, okay, to support your chemical plant design. Okay, so beside that, here are three of the references that actually you can refer in case you want to try to know what are the existing technology or processes that actually they are using in industry to produce a common product. And in these three reference book here, okay, I think they compound, okay, all of the existing, okay, or common processes or technology that we normally use in industry to produce a common product. So means that you can try to, okay, refer or download the references here if let's say you want to try to collect the relevant process pathway or identify all the existing processes of technology that currently practicing and using in the industry, then you can refer to these three reference book here. Okay, beside that, okay, as I told you, okay, when we try to collect the data, compile data, we also need to try to collect the fundamental properties or the physical property of the raw material or even the product that we are going to use or handle in the reaction or technology. Okay, so if let's say the data, okay, you try to refer to the reference book or ebook, or but you still cannot get their data, then the alternative is maybe you can also try to switch on your computer, open the simulation software, and try to get and retrieve the properties of the chemical or the product from the simulation software. Why? Because actually the simulation software, can assist you to simulate your process flow diagram to solve all the mass and energy balance or even thermodynamic of your chemical plant. Because actually inside the simulation software, there is a data bank or database. If let's say the data or the properties, okay, you cannot get it from the reference book, then you can also try to get it from the simulation software. For example, Aspen, HYSYS. that we use in our chemical engineering, thermodynamic, and simulation. Okay, so beside that, okay, if let's say we want to try to compare the price of the product that we are going to produce or the price of the raw material that we are going to use in the chemical reaction, how to get their prices? You can refer to the chemical market reporter. You just Google chemical market reporter. Then in the chemical market reporter, normally they have a list, okay, and they can actually provide you the latest prices of the chemicals and also product. But unfortunately, the chemical market reporter has been discontinued, okay, for publication. So that's why if let's say now you want to try to get the latest prices of your raw material and so product, then you can actually refer to another website we call Chemical Market Analytic, or we call ICIS. Okay. So if I'm not mistaken, the report that provided by the ICIS and Chemical Market Analytic normally is actually based on the subscription. So if let's say you don't want to subscribe the report, then maybe you can refer to the other website or alternative sources in order to get the relevant prices. Okay. So beside that, don't forget, okay, later after you design a chemical plant, you are going to construct a chemical plant. You are going to run or operate the chemical plant to produce your product. And when you try to run the chemical plant, operate the chemical plant, it involves the use of the utilities. For example, okay, you need to use the water to cool down the process, or even you need to try to generate the steam, okay, in order to provide the energy to your chemical plant. Or maybe, okay, you need to supply chemical electricity, the current to your chemical plant in order to operate them. So all the use of the utilities here, you will also contribute, okay, to your capex. What is capex? Oh, sorry, not capex, OPEX. What is OPEX? Operating expenditure. Okay. So if let's say you want to estimate, okay, to calculate the capex or OPEX, then you need to know what is the cost or what is the price of the cold water, steam, and also the electricity that you are going to use and supply to a chemical plant. Okay. Capex is the cost that you need in order to construct a chemical plant here. OPEX, that means the money, okay, that you are going to spend in order to operate the chemical plant here to produce a product. Okay. So if let's say you want to calculate the OPEX, then you need to know the prices of these utilities. And all these utilities can be either, okay, their prices can be get from the local utility company or refer to the appendix that given by the Mr. Peter in the reference book here. Local utility company means, for example, if let's say you are going to construct a chemical plant in Selangor and you want to use the water to cool down your process, then you want to calculate, okay, what is the price of the water that you are going to spend in order to operate the chemical plant here, right? Okay, in Selangor, which company, okay, is going to to manage, okay, or on the water supply in Selangor? Air Selangor. Then in that case, you can refer to Air Selangor to get the latest price of water that you are going to use in order to calculate your OPEX. Okay. If let's say you want to construct your chemical plant in Pasir in Johor, the company, okay, who manage or control the water supply in Johor is Range here. Then you need to try to approach or refer to the official website of Range here, the utility company, in order to get the price of water supply. Okay. If let's say you can get the prices, then no choice. You need to refer to the appendix that given by Mr. Peter in the reference book here in order to estimate the OPEX. Okay. But if let's say you manage to get a price from the local utility company, and also you manage to get an appendix that prepared by Peter, then as a chemical engineer, then you need to decide, okay, which method you are going to calculate the price for the OPEX. Okay, why? Because as I told you, okay, design project, especially chemical plant design, is an open-ended task. Okay, no correct or no wrong answer. The most important is practicable. Okay, is practicable, and also all the assumption and also the element or decision that you are going to make is actually logic. Okay. Also, okay, we can also try to get the relevant data. Okay, for example, the existing chemical plant that is used by our competitor or industry from the pattern. Okay, this one we call pattern search. Okay, so what is pattern search? Okay, if let's say now some of your competitor they already come out a new chemical plant design, and they apply the intellectual property IP to protect their design. So if I'm not mistaken, normally the patent can only last for 10 years. If let's say after 10 years, they want to try to extend again, then they can extend for another 10 years. So meaning that if I'm not mistaken, normally the design, if I'm not mistaken, okay, it can only be protected under the IP maximum up to 20 years only. Okay, after 20 years, what will happen is, okay, normally there is a what we call a company that will handle and assist you to apply the intellectual property. If let's say your patent is already 20 years, then what will happen is normally they will try to disclose and share the patent on their website. This is what we call patent search. Okay, so that's why if let's say they already publish a relevant technology or information on the website, then you can actually try to get the relevant information from the website and support, okay, assist your chemical plant design, okay, later. Why? Because maximum can only protect for 20 years. After 20 years, then it will be disclosed to all the public, okay? This is what we call patent search. If let's say the patent can be found on website, then you can consider as a reference, okay, to support your design, okay, later. Okay, so very, very important. Okay, as I told just now, okay, no matter you are going to come up with a new design or maybe you are going to modify the existing technology that is currently using by other industry, the most important, profit. Because you are not a charity, you are not a NGO. Okay, the main motivation, the main objective why you want to set up and design and set up and construct a chemical plant, money. Then of course, okay, even though you want to make profit, okay, but you cannot sacrifice, okay, the environment and also the social, okay, and also, okay, to make sure your plant, okay, can actually produce high amount of product, okay. You also need to make sure the performance of the chemical plant that you are going to design is always, okay, optimal, okay. Okay, so look at here. I want to explain something. Okay, so as I told you just now, okay, if let's say you want to design a chemical plant, first step, okay, first you need to identify, okay, what are the possible technology, processes, or reaction that actually get applied to produce our product. And under all the possible reaction, okay, you need to try to collect the relevant information, okay, that I try to explain just now based on the references or platform that I shared with you just now. Okay, even though you already have all the data and information with you, and now if let's say, okay, you want to try to proceed to initiate and start with the chemical plant design, okay, normally, okay, the design of the chemical plant is not that simple. And most of the time, all the decision that we are going to make, okay, in our chemical plant design, it mainly depends on our experience. Okay, so that's why it's important. Okay, and it's good if, let's say, we can try to involve some of the very experienced chemical engineer in our design group in order to support us. Okay, to work together. Okay, in order to come up with a chemical plant. Okay, so you may ask, sir, if let's say we all are fresh and young graduate, young chemical engineer, and we don't have any experienced or senior engineer, chemical engineer in our team, then how? Then what we can do is we can try to refer to the heuristic that actually shared by the experienced engineer or even some of the very expert, okay, that share in the scientific journal in order to assist us to come out, okay, to support our chemical plant design. Okay, what is heuristic? Heuristic, that means, okay, the expert or professional or the experienced chemical engineer they try to list out all their experience, okay, in point form or table form in order to consider as a reference, okay, to support us, okay, to make our decision, okay, in our chemical plant design. For example, okay, if let's say now I want to separate a liquid mixture, there are a lot of possible technique or process we can apply to separate liquid mixture. For example, distillation process, or what we call the liquid extraction. All these processes can be used to separate the liquid mixture, but you totally have no idea which method, okay, I need to apply, which one is more economic, then if let's say in that case you have problem, you don't know which selection or decision you are going to make, then in that case you can refer to the heuristic. And the heuristic, okay, is actually provided in some of the reference book, okay, and you can try to refer to the heuristic that actually provided by the expert. Then you try to search, is there any relevant heuristic shared and recommended or suggested by the expert in order to support our decision here, which method, okay, we need to apply in our design. Okay, this is what we call heuristic. So in other words, that heuristic is actually can be considered as the experience sharing, okay, by the expert, okay, in order to support us to make the most suitable decision in our chemical plant design. Okay, okay, for the heuristic, okay, we will try to discuss more in our next chapter, okay, chapter number 3. Okay, so now we proceed, okay, so now, okay, just now we already identified all the possible reaction or processes that we are going to use in order to produce our product. Okay, and all these processes and technology, they will involve the use of different unit operation and also different raw material. So that's why, okay, we also need to identify and know what are the processes or unit operation or even the raw material that we are going to use, okay, in the possible reaction in order to produce our product. Okay, and some more, okay, if let's say now you want to produce the Panadol, let's say there are 3 different processes or different technology can be applied to produce a Panadol. 1, 2, and 3. Okay, and each technology, each process here that involve the use of different raw material and also different unit operation or the equipment. And okay, the sequence, how are you going to arrange the unit operation under each of the process here? You can also further come up with a lot of different possible, okay, process flow diagram. So for example, for the first process here, you need to use a decision column, and also you need to use let's say a flash tank. So okay, under the first process here, you need to use a flash tank and also a decision column. Which unit operation should come first? You need to install the flash tank first, then only the decision column, or maybe the ballet. So due to the different arrangement of the unit operation, different connection of the unit operation, then later for each of the process here, you will come up with another, okay, a lot of different possible process flow, okay, different process flow diagram, even though the process or technology that you are going to use is similar. So that's why you see, okay, sometime in our process chemical plant design here, okay, what we will do is, I try to remove. Okay, don't remove. Never mind. Okay, so that's why sometimes in our chemical plant design, we will use the synthesis tree. This one we call synthesis tree. In order to give us a clear picture how many processes, okay, actually can be applied to produce our product, and under each process, how many possible arrangement of the unit operation we can come up with, okay, in order to give us, okay, a clear picture actually how many possible pathway, okay, actually we can follow before we finalize our chemical plant design, especially the process flow diagram. Okay, so okay, first, okay, so far any problem before we proceed? Okay, Kuma, do you have any problem with the Panadol here?
No.
No, okay, thank you. Okay, Kuma, what are you doing? Why so quiet?
I'm in the class.
Oh, in the class. Okay, good. Okay. Okay, so you see, just now we already collect all the relevant data, and form a database. Once we have all these relevant important data or data base, then what we can proceed is we can start to create a process. Okay, we call process creation. Okay, process creation. So under the process creation, we will try to make use of all the collected data and information in order to start to initiate or create a process. And normally under the process creation, we will start to try to identify, okay, all the possible combination, okay, similar to what I explained to you just now. Okay, all the development of the design database and also the process creation, all of them are actually under the second stage of the framework that introduced by Mr. Peter. Okay. Okay. Where it is? Okay. Yes, correct. Okay. Okay. So wait. Okay. So now, okay. Just now we already create a process under the process creation step. Okay. So under the process creation step, we also need to decide, okay, what is the operation mode, okay, the what we call the operation mode that we are going to use in our chemical plant design. Operation mode, that means, for example, batch operation, continuous operation. This one is known as operation mode. Batch operation, that means you dump in, transfer in all the material into a unit operation, okay? Then after that, you cover it, okay? Run the reaction for 30 minutes, or let's say 30 minutes. Then after 30 minutes, only you try to get your product from the unit operation. This one is known as batch operation. The what we call the concept is a bit similar to our rice cooker. Okay, you dump in, transfer in all the raw material, then you will only remove the product, okay, at the end of the process. Okay, maybe after 30 minutes or maybe 1 hour. But continuous operation is different. For continuous operation, the raw material is actually keep feeding into a process plant. And at the same time, the product is actually keep removing out, okay, extracting out from the chemical plant. Okay, this is what we call continuous operation. Okay, so that's why, okay, we need to try to select the suitable operation mode, okay, for the reaction, the possible reaction, the possible pathway that you identify. Okay, so okay, now we try to compare what is the advantages and different and disadvantages, okay, of our batch and continuous operation. Okay, so first, what is continuous operation? Okay, I told you already. The material keep feeding in, product keep removing out from the chemical plant. And normally this operation mode is normally applied if, let's say, we want to produce the common product or common chemical. For example, plastic, paper, and some of the common chemical solvent, then normally we will use the continuous operation. If, let's say, we apply the continuous operation, the impact that given to our design is it can reduce the labor cost. Labor cost, that means later the manpower that you need to in order to operate the chemical plant, okay, will become cheaper. Okay, why? Because the manpower you need, okay, is reduced if, let's say, you use continuous operation. Why? Because the process is actually keep running, okay, all the time. Beside that, okay, the control system or the process control is also better for continuous operation, okay, if, let's say, compare with the batch operation. And also, if, let's say, we use the continuous operation to produce our product, and normally the quality of the product that we are going to produce will also be more uniform. Okay, but if, let's say, when we try to do some literature review, or when we try to read the relevant journal article, and if, let's say, the expert or maybe the scientist, they already get the supporting information or the supporting data or supporting scientific finding to prove that, okay, even though this chemical is a common chemical, but it is good if, let's say, we can use a batch operation mode. Why? Because maybe the quality of the product that you are going to produce will become higher, or maybe is good, okay, or more efficient in order to produce your product, then only we will proceed to use the batch operation mode. If not, normally we will, okay, stick with the continuous operation. Okay. Okay, beside that, okay, just now I try to explain the batch operation mode and also continuous operation mode. But some of the processes, they will combine the characteristic of batch operation mode and also the characteristic of continuous operation mode. So if, let's say, they combine the characteristic of both of these operation mode, then is considered and known as a semi-batch operation mode. Okay. Okay. So normally the batch operation mode or semi-batch operation mode, if, let's say, we want the amount of the product that we are going to produce is very small, then yes, normally we will try to okay, proceed with the batch operation mode. If let's say the amount of the product that you are going to produce is high, then we will normally apply the continuous operation mode. Okay, and also if let's say the product that you are going to produce, okay, it demands is intermittent. Okay, demands is intermittent means some of the product is actually very special. When you produce a product already, right? Okay, you cannot directly to supply to your customer. Okay, you need to try to get some of the sample, then pass to your customer. Okay, they will probably look at the sample to see whether this sample, the quality is suitable or not. Is yes, then only you can proceed to supply to them. If let's say they reject, then you need to continue. Okay, maybe you need to continue a process. Okay, or how in order to make sure the process, okay, can produce a product. Okay, that can fulfill or meet the expectation of our customer. Or even in chemical industry, some of the process, right? Okay, they need to do the quality checking. Okay, that means before they discharge the product out from the unit operation, they want to do perform some quality check. Okay, to make sure the product is actually can meet the quality standard. Then, okay, once the product is produced in the unit operation, okay, they will try to get some of the sample out from the unit operation, pass to the what we call uh, the quality control department to do the quality checking. Okay, once they say yes, the quality fulfill our ISO standard. Okay, then only they can proceed to release out the product from the unit operation. Then only can be supplied to the market. So this is what we call demands is intermittence. If let's say your product, okay, is actually want to fulfill the requirement that given by the customer, or maybe you want to do the quality checking, then it's good if let's say you can use the batch, okay, operation. So also, okay, if let's say the raw material or the process that you are going to handle is very hazardous or toxic, okay, that means the process that you are going to use, okay, involve the use of hazardous or toxic chemical, then is also good if let's say you can use batch operation mode. Okay, why? Okay, due to the safety reason. Okay. Here is the comparison between the continuous and also the batch operation mode. Okay, you see for continuous, okay, process, normally we will only apply if let's say the production rate is higher than 5 multiplied with 10 power or 6 kilogram per hour. If not, then normally we prefer the batch operation. Okay, normally used, okay, to produce a common chemicals. Okay, this one is good, okay, if let's say the product that you are going to produce is intermediates. Okay, okay, because the process here is continuous. So that's why if let's say you want to try to monitor the process, then it will become a bit difficult. Okay, but for the batch process here, okay, because it's a batch process, and that's why the monitoring process is also simple and easier a bit compared to the continuous process. Besides that, for continuous, the installation cost is high, and also the maintenance cost is higher. And for batch, the installation cost, okay, is lower, and also the maintenance cost is lower. Why? Because the production rate that is going to be handled by the batch reactor here or the batch process here is smaller than the production rate of our continuous process. Since the production rate is lower, so that's why the size of the unit operation that you need is also smaller. So that's why the installation cost is lower and also maintenance cost is also lower. Okay. So beside that, if let's say the process of technology that you are going to apply or include in your chemical plant design is an established process or established design, then normally we can directly to use the continuous operation mode. That means we can directly to carry out the continuous, okay, production of the product. Why? Because it's an established design. Means the maturity of the technology or process that we are going to use is actually mature enough. Okay, okay, that means very stable and established. But if let's say now we want to try to create a new process, especially those just invented in the lab scale, but now we want to try to commercialize that process to make it become bigger in order to practice in industry, then it's good if let's say we can start with the batch operation, okay, okay, and also some of the process it require a large residence time in the reactor. Then in that case, we also prefer the batch continuous, batch operation mode. Okay, and also if let's say the chemical that you are going to use is very dangerous or hazardous, then you are also encouraged to use the batch operation mode. And one more thing, okay, in most of the chemical reaction, we need to install or use the catalyst. Okay, so if let's say the process that you are going to use and apply, it will cause what we call the fouling, okay, on the surface of the catalyst. Okay, then okay, we will use batch operation mode. If let's say the fouling problem is not that serious, then we can go for the continuous operation mode. Okay, do you know what is fouling? Fouling, that means the impurity or the byproduct, they will stick on the surface of the catalyst and try to reduce the efficiency or the conversion of the reaction in the let's say the reactor. Okay, it's what we call fouling. Okay, so these are the guidelines or maybe the factors that actually we can consider before we decide which operation mode that we are going to use. Okay. And also, okay, let me check. Okay, yes. Okay. Okay. And also, okay, similar to what I told you last week in our previous lecture and tutorial, okay, later if let's say, okay, you already finalized your chemical design, okay, and you want to proceed to design the mechanical part of the unit operation, okay, some of the information you also need to know. Okay, for example, the composition of the process stream you are going to handle, what is the physical state of the process stream you are going to handle, okay, what is the temperature and pressure you are going to handle in the reactor or in the unit operation, or even what is the volumetric flow rate or maybe a mass flow rate inside the pipeline you are going to handle. All this information, if let's say you already collected, make sure you include in your data bank or data in the list, okay, so that later when you want to design the what we call the mechanical design of the unit operation, then you can directly to refer to the information here. Okay, so far any question regarding to the stage 2 of the framework that introduced by Mr. Peter? Okay, Shini, do you have any question regarding to my explanation just now? So far, I explained all the tasks, all the section that we need to do and address under the stage number 2 in the framework that introduced by Mr. Peter.
No questions, sir.
No, clear? Okay, thank you. Okay, done with the second stage. Okay, now we want to proceed to the third stage, okay, of our framework that introduced by Mr. Peter. Okay, just now we already identify all the possible reaction or all the possible pathway to produce our product, okay? And also the references, the platform that actually we can refer to collect the data. Okay, and also the selection of the operation mode. Okay, so now we will proceed to the third stage here. Undertake preliminary process synthesis of this solution. Okay, now you already identify all the possible pathway to produce a product. Then now is time we need to try to further, okay, to identify, okay, what are the unit operation, okay, sorry, the operating condition, okay, that we need to apply in the unit operation of each of the possible reaction pathway here, okay, because you are going to use different processes, different technology. So that's why I'm sure later the operating condition will also be totally different. Then under the stage number 3 here, okay, you need to identify, okay, the operating condition, for the unit operation that you are going to use under each of the possible reaction pathway here. For example, if let's say now you want to carry out a chemical reaction, then you need a reactor lah. Then you need to identify what is the operating condition you need to use in the reactor. Okay, for example, okay, for the reactor, you want to carry out a chemical reaction. Okay, first you need to identify the operating condition. The main operating condition is temperature and also pressure. But at the same time, you also need to try to know what is the conversion that actually we can achieve under the selected operating temperature and pressure here. Okay, and also what is the reaction rate, okay, of the chemical reaction that you are going to carry out here under the selected temperature and pressure. Okay, is there any byproduct will be produced? And also is a irreversible chemical reaction or reversible reaction? If let's say the irreversible reaction, okay, sorry, if let's say it's a reversible reaction, what is the equilibrium conversion? Okay, so you need to identify all the relevant information, okay, related to the chemical reaction also in the step number 3 here. Okay, so beside that, okay, if let's say now you want to separate a mixture, then of course you have to know what is the suitable process you need to use. And under the selected suitable process, what is the operating condition? Okay, and also if let's say you are given a liquid gas mixture, you want to separate them. Okay, this one we call phase separation. Then you also need to know what is the operating condition that you are going to use. Okay, then if let's say in the process stream it involves the change of temperature, meaning that you are going to install a heater, a cooler, or even a heat exchanger in order to adjust the temperature of the process stream, in order to address the temperature difference, okay, in the process stream. And if let's say it involves the pressure difference, you want to adjust the pressure to make them become equal or similar to each other, okay, then what you need to do is, okay, you can try to install a pump or compressor. And if let's say you want to try to combine 2 different process streams together, then you need to apply a mixing process. Then under the mixing process, you have to know okay, what are the process streams you are going to mix, okay, and also the temperature and condition. Okay, these are the tasks that actually we need to complete under the stage number 3 in the framework that introduced by Mr. Peter. Okay. Okay. As I told you just now, okay, for chemical reaction, their chemical reaction is mainly depends on temperature and pressure. So that's why, okay, if possible, okay, when we identify the suitable temperature and pressure, if possible, we try to get the optimum operating temperature and pressure as well, to make sure we can try to minimize the production of byproduct and maximize the amount of the product that we can produce. Okay. Okay, So as I told you just now, okay, under the each different possible technology and process you are going to apply, since that involve different the use of different unit operation, and some more the sequence how we are going to connect of the unit operation here can be different. So that's why under each of the chemical process, possible chemical process here, they can come up with a lot of different possible, okay, what we call the possible arrangement for the unit operation. And since the arrangement of the unit operation difference, later it will influence the final performance of our chemical plant or even the quality of the product that we are going to produce. Okay, so this one, as I told you just now, we call synthesis process synthesis 3. Okay, you can actually consider as one of the method. Okay, we can draw out all the possible pathway in order to give a clear picture, clear diagram. Okay, in order to support our decision making. Okay, in the chemical plant design. Okay. Okay, so far any question? Remember, under the stage number 3, okay, we need to start to try to identify the operating condition, okay, for all the processes that we are going to deal in the selected possible reaction pathway or process pathway. Okay, so far, do you have any question before we proceed? No one? Okay. Okay, just now I just give you an example based on the chemical reaction. Because just now I told you, okay, not only the operating temperature and pressure. If let's say you want to carry out chemical reaction, you also need to know what is the conversion under the selected operating condition, okay? And also the reaction rate, okay, and so on, okay? And all this information we need to try to gather at the same time to make sure they are available and ready, so that later when we proceed to the subsequent stage in the framework that proposed by the Mr. Peter, later we can directly to refer this information to proceed to our design. Okay. So if let's say now, I give you another example. You want to separate a mixture. Okay, let's say you already decide you want to use a distillation column. Okay, then not only the operating condition, not only the operating temperature and also pressure you need to identify in the column at this stage, but also you have to know okay, what is the efficiency, okay, of the separation performance under the selected, okay, operating condition. Is there any, let's say, any reaction will take place inside the distillation column or not? Okay, let's say, for example, all this relevant information you also need to, okay, identify and get it ready. Okay. And if let's say now you want to try to adjust the pressure, okay, you want to try to pump the liquid to increase the pressure of the liquid stream before it fit into the unit operation. Okay, of course you have to know what is the final temperature you want to achieve, and also what is the efficiency of the pump you are going to use. Okay, so later you need to calculate, okay, because you need to perform some calculation, and you may need all this data, okay, to support your calculation. Okay, so that's why when you try to collect the operating condition, okay, then you can also try to get more the data to get them ready in order to support calculation. Why? Because some of this data, right, okay, you might not be able to collect under the stage number 2 here. Okay, so that's why if let's say the data are not collected and compiled, okay, under the task under stage 2 here, then at least at stage number 3 here, when you try to refer to the relevant references, okay, and you have this important information, then you can also try to gather them together, compile and include them in the database that you already established in order to further facilitate your design later. Okay. Okay. So look at here. Just now I told you already. Okay, when we want to produce a product, let's say Panadol, what we will do is we will try to identify all the possible technology and processes that actually we can produce Panadol or our product. Okay, so you might ask, sir, so many alternatives, so many processes, how we are going to select the best one, huh? The first criteria that we use to assist us to try to do the screening to eliminate the bad chemical reaction or possible rough process pathway is money. So meaning that I told you already, the top priority, because we want to make profit, we want to generate money. So that's why, okay, even though we already identified different processes or technology, but okay, first, okay, we will do the screening. We will try to select the best technology among these chemical processes here. How we are going to do the screening? Based on what criteria we are going to select the best one? Based on the profit that we can get. And actually there is an equation we can apply in order to calculate the gross profit that we can get or we can make based on all the identified possible reaction or process pathway here. Okay, and the method we call economic potential. Means that there is an equation. We can use that equation to calculate the economic potential, short form we call EP, to evaluate whether the identified process here can generate money, can make profit or not. And the value that we get for the economic potential, okay, it can actually also consider or represent the gross profit that we are going to make based on the identified chemical reaction here. If let's say the economic potential is a negative value, that means that process we cannot get any money from this process here. So means that, okay, if let's say we try to produce a product by using the, let's say, the second method here, but the second method here, the economic potential after we calculate is actually a negative value. That means at the end, we cannot make profit. We rugi. So in that case, what we can do is we directly ignore the second process here. Then we can terminate at here, then we no need to proceed further. So if let's say the third one is also negative, we cannot make profit, then we can also terminate here. Okay, we no need to proceed further. So that's why it can actually assist us to simplify and reduce all the possible design that we going to come out at the end, okay, of the stage here. Okay. So if let's say now I already eliminate the second and the third processes here. Now we have the first and the last one here. This one, the economic potential is a positive value. And this one is also a positive value. Then, sir, how I'm going to select all of them are positive and some of their value are actually very close to each other. How I'm going to select? Then in that case, we need to proceed to try to select the suitable process based on other criteria. So what are the criteria we can actually try to consider in order to support before we make the final decision? First one is the technical factor. We can try to consider the technical factor. What is technical factor? For example, the process, okay, the process that you are going to apply, the first one and the last one, is it a continuous or batch operation mode? So as I told just now, the characteristic of the continuous and batch operation mode is totally different. Some of them, okay, is actually the manpower that you need is actually lower. Okay, some of them, the installation cost is cheaper. Then, okay, it can also influence your decision. Okay. Beside that, okay, for the what we call the different process, the first one and the last one, what is the year of the product that actually we can achieve? Of course, we prefer the high year. High year, that means the higher amount of the product that actually we can produce, okay, by using the process. So beside that, how about the technical difficulties? Okay, technical difficulties. That means, is there any difficulties we are going to face? Okay, based on the selected process of technology. Okay, so based on the selected technology that we are going to use in our design, does it involve any control system or safety control valve that is very special? Or do we need to include a very special equipment in our process? If let's say we select the first process, okay, all this you need to try to consider. And all of them are actually considered under the category, big category we call technical factor. Okay, beside that, okay, how about the energy consumption? Different processes, okay, require different amount of energy. Then of course we will try to minimize the use of the energy then we will try to prefer the one, okay, with the low energy consumption. Okay, beside that, okay, so is there any very special and uncommon equipment you need in the selected process? And also, if let's say in future I want to modify this process, okay, is it any potential? Can we modify the plant easily? We also can consider, okay, in order to support, okay, our decision making. And beside that, okay, for the process or technology that I'm going to select, does it involve any hazard, okay, hazard or the toxic chemical? Okay, if possible, we want to avoid that. Okay, all are considered the technical factor. Okay, and of course, you need to consider the material that you are going to use in the technology and also the process you are going to use also. So please make sure the supply of the raw material is actually sustainable. Okay, the sustainable in the context here means we need to make sure the supply of the raw material is actually continuous, meaning that we have sufficient supply of the raw material in order to allow us to produce the product that we want to produce. Okay, so if let's say now, okay, you want to produce a Panadol, let's say every 1 hour you want to produce, let's say every 1 year, sorry, every day, you want to produce 2,000 kilograms. But the raw material, the supply is very hard to get from the market. And maybe based on the amount of the raw material that your supplier can supply to you, can only allow you to produce, let's say, 500 kilograms per day of Panadol. Then you really need to consider that. Why? Later, you will limit the maximum output, the maximum amount of the product that you can produce. And it can directly impact the total amount of profit that you are going to generate by using your plant. And also, if let's say later your customer, their request, their booking is actually every day 2,000 kilograms, but you're only able to provide 500 kilograms, then how are you going to reply your customer? Okay, so that's why we need to make sure the supply is continuous. And also different raw material require different processing method. You also need to, okay, evaluate the processing method. And also different raw material, okay, or the material require different storage requirement. Some of them, let's say they need to keep, okay, under the how do you say, the temperature below -0°C. Then in that case, you need to come up with a very special storage, okay, tank to store the raw material. And because it will be kept under below the negative, okay, below the 0°C, then later you need to, okay, consume more energy to make sure to keep the temperature as low as possible. Okay, and also the material, okay, that you are going to use to construct the storage tank, or the unit operation that you are going to handle the raw material that you are going to use, you will also directly influence your cost also. Okay. So beside that, okay, different processes, okay, since they use different raw material, different chemical reaction, then of course the byproduct and also the waste they are going to generate will become totally different. Then in that case, you need to consider the amount they produce, okay, whether they can be considered as to generate the side income to supply to other customer or not, okay. If not, if let's say they are toxic and hazardous, okay, how we are going to handle them, okay. Will it be possible we try to construct a chemical plant, sorry, the treatment plant in our chemical plant to handle this waste that generated? Okay, any huge negative impact will be given by this waste product to the environment. All this we need to try to consider as well. Okay, if possible, we try to avoid the generation of the waste product, especially those hazardous and toxic chemical or waste product. So beside that, okay, as I told you just now, different processes, different technology, okay, then need different unit operation or equipment. Then you need to make sure the equipment or unit operation that you are going to use is actually available in the market, okay, can be purchased or get it from the market. And also depends on the process you are going to construct. Okay, you are influenced and determine the material that you are going to use to construct the equipment here. And you are directly influence the cost of the equipment. And also different equipment, they need different maintenance and installation costs. And some of the very unique or special chemical reaction, they may need a very special equipment. Then in that case, okay, you will also influence the maintenance and also installation cost. Okay, because you cannot get it from a local market. Okay, sometimes you can only get it from, let's say, from Europe or overseas. And sometimes you need to do the maintenance. We don't have any expert know how to maintain this one. We need to try to get the expert or maintenance team from Europe or overseas. Then it will also influence our cost also. And also some of the unit operation or equipment, they are very unique. Okay, some of the spare part or component they need to try to replace from time to time to ensure their efficiency to produce a product you want. Then you need to consider that. Okay, how long? Okay, how frequent you need to replace a component, and how what is the cost? Okay, and what is the time you need in order to replace a component in the equipment. Okay, or okay, if let's say the selected technology or process, okay, if let's say you need some very special or unique design, then you need to make sure you have the technology, not the technology, or the very professional team and expert can actually assist you and support you to come up with this special design. Okay. And also, okay, the plant location. Okay, it can also determine, okay, it can also support, okay, our decision making to select the best technology or process. Okay, plant design. Plant location. Okay. Beside that, okay, you also need to consider the process consideration. Okay, the process that involved in the technology. For example, for the selected technology, is the technology available, okay, in the market? So you also need to consider, okay, the vision and mission of your company. Why? Because sometimes your boss, they want to do a new investment. They want to produce a new product. Okay, they want to produce a new product. Okay, if let's say now your company is a food and beverage company, then of course their vision and mission is to produce the, let's say the #1 food and beverage in Malaysia. But suddenly you propose, or in the process that you select, it involves the production of, let's say, dynamo, then it sounds like a bit weird leh, because your company is a food and beverage company, and suddenly you propose your boss, okay, to produce dynamo, okay, and some more, okay, the mission and vision is want to become the top, okay, food F&B company in Malaysia, and now you suggest your boss to produce dynamo, then in that case, it a bit weird lah, and it cannot tally with the mission and vision of your company. Then in that case, maybe you need to try to reconsider the project that you are going to produce, okay, and propose to your boss, okay. Okay, and also, okay, consistency of the product. So meaning that if let's say in your company, okay, you are going to produce the food and beverage, okay, you see they produce a lot of different food and beverage, Coca-Cola, Pepsi, 100 plus and so on, okay. But suddenly you pop up, you want to produce a dynamo, not only a pivot, and later in the company, okay, normally they will plan that, okay, the product, okay, the production line that produce the product that is actually irrelevant to the mission and vision and mission of the company, you are trying to disturb or influence the consistency of the product that is going to produce in your company. Okay, so these are the process that you are going to, okay, consider. Okay, beside that, okay, we go back to the plant location. Just now I said we can also try to use the plant location to support our decision making. Of course, different process that involve different amount of the unit operation or equipment you want to install. Then you are determine the total, the what we call the total land area they require. Okay, and the land area, total land area they require is actually directly proportional to the cost, the investment that you are going to do in order to purchase the land to construct the chemical plant. Then you need to consider that, okay, in order to support your decision making also. And also, how about the transportation, the facility? So later when you produce a product, how are you going to send it to the market? So you need to consider the transportation, okay? And also, is there any manpower nearby the what we call the location, okay, that you are going to construct a chemical plant, okay? So if no, okay, then later you need to try to get them to assist you and support you in order to, okay, operate the plant. And also some of the process is very unique, okay, we don't have any expert in local market. Then in that case, we need to try to get the expert from overseas, let's say from Europe, in order to assist us, okay? So, okay, so all this, okay, you can actually try to consider, okay, in order to support, okay, your decision making before you make the final decision to select the suitable process to produce your product, okay. So beside that, okay, under the plant location, okay, we can also consider the proximity to market. Proximity here, that means the distance. Okay, so how to say? Okay, so based on the product you are going to produce, then of course you have some of the targeted or expected market. So if let's say you want to supply your product to the consumer or user, let's say in Petaling Jaya, okay, then if let's say your plant, okay, is constructed in, let's say, in the industrial area in Subang Jaya, okay, then what is the distance between your chemical plant and also the targeted or expected market? Okay, So the distance, okay, can also be the factor in order to support, okay, your decision making in order to select the suitable, okay, process to produce the product. And also climate, okay, if let's say the selected area, okay, if let's say based on the record, okay, sometime the what we call the flood, okay, then in that case we also need to avoid that region also. Okay. So beside that, okay, so different, okay, different technique, different technology, different process that involve the use, okay, that require different costs, okay, different material that you are going to use, different costs. Of course, the energy consumption different, they also need different amount, then you will also determine influence the cost. And also, okay, the what we call the devaluation, okay, of the process we need to consider. Okay, other fee charges, okay, is there any other fee charges involved in the selected process? We also can consider that. And also the processing method that involved in the selected process, we need to consider. Okay, any special labor requirement, if let's say the expert can only be get from overseas, then you will also increase the cost because we may need to pay them more. So what else? Okay, also the pattern right. Okay, so if let's say, okay, you want to try to, how to say, if let's say now you want to try, you already come up with a new design, you want to protect your design, you want to apply the IP, you also need to apply and pay. Then that one will also determine your cost also. Okay, we need to consider in our cost calculation later. And the most important, we need to make sure, okay, the process that we are going to select and apply in our chemical plant and design is actually, okay, eco-friendly, okay? It won't give a huge impact, okay, to the environment or social, okay? This is all the costs that we need to consider. So if let's say the process that you are going to use is not eco-friendly enough, it generate a lot of waste product, and some of these waste product can be dangerous, give huge impact to the environment, then you need to treat them, okay, before you can release them to the environment. So if in order to treat them, you need to come out with another process plan in order to treat this waste product, okay, we call treatment plant. Then in that case, it can also further increase the cost that you are going to spend, okay, in the selected process. Beside that, okay, the last factor, okay, we need to consider is time factor. Different process, they need different what we call they have different project completion deadline. Some of the processes or technology can be completed within 1.5 year. Some of them they need 2 or 3 years, okay, especially those that involve a very special or unique operation or technology, and you need to get the expert from overseas, okay. And also the market timeliness, okay. So that means, okay, you need to consider, is it the right timing, okay, after you complete the plant here and start to produce a product, is it the right timing, okay. Do you still have the ability, okay, to compete with your competitor, okay, this one you need to consider. And also don't forget what we call the inflation, okay, what we call value of money, we need to consider later in our cost calculation and also time factor also. Okay, so these are some of the factors that actually we can try to consider in order to support our decision making. After we eliminate, okay, those chemical reaction that is not economic potential enough, then in order to further to support and identify the final chemical reaction or technology that we are going to use in our design, then here are some of the consideration that actually we can try to consider, okay, in order, okay, to support our decision making for our selection. Okay. Okay. So sometimes, especially those of the new technology or process, okay, some of the data they are actually cannot be found or not provided or not available in the reference book or maybe in the journal article. Why? Because they are totally new. So in that case, okay, we still need those important data or information to proceed to our chemical plant design. So since this technology that you are going to use is actually new and we don't have the data, then what we need to do is sometimes, okay, we need to conduct some experimental work in the lab in order to collect those data that require in our design or to support our decision making. Or even sometimes they will start to try to construct a pilot plant. Pilot plant, that means a plant, indoor plant, and their scale is actually much smaller than what we are going to construct. And we try to run the process or reaction or technology by using the pilot plant, okay, in order to gather the relevant information in order to support, okay, our decision making and our design later. Okay, so far, any question? Okay, before we proceed. Edmund, do you have any question you want to ask me? Oh, Edmund missing in action. He don't want to reply me. Okay, never mind. Okay, we proceed. Okay, I miss you so much, Edmund. Where are you now? Okay. Okay. So as I told you just now, okay, some of the reaction, so not reaction, some of the technology or process, they are totally new. You don't have the relevant optimum operating condition, or maybe there are some of the important data cannot be found or missing. Then in that case, what we will do is we will try to do some experimental work or construct a pilot plant to try to collect all this important information. Okay, it can be the operating temperature or pressure of the process, new process, or maybe we can try to get the important chemical reaction, rate of chemical reaction expression, okay, in order to allow us, okay, to support our decision making and proceed, okay, with our chemical plant design, okay. Okay, so just now, okay, we already eliminate the chemical process or technology that is not economic, their economic performance is not good enough. We already eliminate based on the calculation of the economic potential. Then after that, we will try to identify the last or the most potential technology or process based on the other factor that I try to share with you just now. Okay, once we already identify the best technology, then what we will do is we will try to proceed to prepare the process flow diagram. What is process flow diagram? This one. This is what we process flow diagram. Okay, before we can proceed. But of course, similar to what I told you just now. Okay, even though we already selected the best technology or process to produce a product, but since it involves the use of different unit operation and the arrangement and sequence of the unit operation here, that can actually directly, okay, give the impact to the quality of the product that you are going to produce. So that's why, as I told you just now, okay, under the selected chemical reaction or technology, you can actually come up with a lot of different possible, okay, process flow diagram due to the different arrangement and the connection of this unit operation. Okay, but of course, as a chemical engineer, you need to know lah, okay, which unit operation should come first, okay, in order that later the design that you are going to produce at the end of the project here can actually give you the optimum chemical plant design. Okay, and here the process flow diagram here, it not only will try to provide us the information how the raw material is going to be processed in order to produce a final product. However, based on the process flow diagram here, it can also provide us the qualitative and quantitative information, or even the combined qualitative and quantitative information. Okay, for example, what is qualitative information? Okay, if let's say you try to indicate the operating temperature, pressure, or even the direction of the flow of the process stream in the process flow diagram, right? All this information is considered as qualitative, okay, information. If let's say you already try to calculate the mass and energy balance, okay, and indicate and prepare a summary table immediately, okay, after after showing the process flow diagram, or maybe you directly include the heat or energy balance, okay, or the mass balance directly in the process flow diagram, then it will provide us a quantitative information. Then directly from the process flow diagram, we can directly know what is the amount and energy that we are going to handle in each of the unit operation and also in the process stream, okay, and also the operating condition. Okay, this is what we call provide qualitative and quantitative information. Okay, before we proceed, okay, to finalize our design. Okay, so inside the process flow diagram, okay, this one should be no problem. Okay, you know already. Okay, you learned before. Okay, you will try to include all the unit operation that require in the process flow diagram, and also the pump or compressor that require in the process flow diagram. You will also include them, okay, in order to connect them together to produce your final product. And the pump compressor, they are considered and known as auxiliary equipment. Okay, and actually the process flow diagram, okay, you learned before. Actually, you can try to directly to draw the process flow diagram by using the simulation software. For example, Aspen HYSYS. Then after, you can directly to give the instruction to Aspen HYSYS to ask the Aspen HYSYS to try to simulate the material and energy balance for the process flow diagram here in order to generate the summary table. Okay. Okay, this is the example. This is the example of the process flow diagram. Okay, once you finalize the process flow diagram, then only you can proceed, okay, to prepare, develop the P&ID. P&ID, that means you will start to try to identify the variable that you are going to control in all the unit operation or process stream in order to make sure the plant can be safely operated. And based on the variable you identify, you are going to design a control system, okay, to try to decide, okay, what is the variable and also the process stream that you are going to control and adjust to make sure the plant, okay, can always be operated, okay, at the set point, okay, or the expected, okay, operating condition. Okay, this is the example of the P&ID diagram. Okay, this one should be no problem because you learned in the process control already. Okay, I just try to recap on it. Okay, once we already develop, okay, the P&ID diagram, what we need to do is now, okay, last stage, we can proceed to the piping layout. Okay, that means now we can proceed to decide how we are going to connect this unit operation together by using the piping. Okay, where you should try to install the pipeline. Okay, what is the orientation of the pipeline? Okay, you need to consider them under the piping layout here. Okay, for example, this one is the piping layout. Okay, it depends on how you are going to arrange the unit operation here and how are you going to process the raw material. Then you will decide how are you going to connect them together. Okay, so normally the piping here is very important. Okay, we can only design and develop the piping layout after you complete the P&ID diagram. Why? Because the loops, the control system that you are going to install, all of them will actually determine how the pipe here is going to connect and where you should try to install and place the pipeline and also their orientation. So this is also a reason why the piping layout can only be prepared after we complete the P&ID diagram. Okay, but of course, when you try to design the piping layout, okay, especially the location and also the orientation, there are a lot of factors you need to consider also. For example, safety aspect. You need to make sure the location that you are going to install a pipeline, it won't result or give another new risk. It will give a new risk, okay, to the operator or engineer or worker in the chemical plant. Okay, and also connection. You need to consider which equipment you are going to connect, how you are going to connect. Okay, and also make sure when you try to design the piping, the location orientation, you need to make sure they are actually accessible. They can be accessed easily by the operator and also the maintenance team to do the maintenance or maybe some of the troubleshooting. Okay, and also, okay, the economic piping, because you are going to design the piping layout, okay, of course, you need to decide what is the diameter and length of the piping you are going to use and install. And you need to play, okay, pandai to play with the diameter and length so that you can try to get a pipeline or piping that is big enough to transmit the process stream. And at the same time, it can also, okay, reduce the cost that require to that you need to invest, okay, for the piping here. Okay, and also you need to consider the heat and material transfer. Material transfer, that means you need to consider what is the amount or volume or weight of the process stream you are going to handle and transmit in the pipeline. If let's say the weight, the mass flow rate or the volumetric flow rate is high, then you need to consider the altitude. Okay, you need to reduce the altitude. If not, okay, if let's say suddenly the accident happen, how? Okay, so you need to consider that. So that's why you need to consider the material transfer. Okay, if let's say the weight or the flow is high, then you need to lower down the altitude, okay, of the pipe. And also you need to consider the heat transfer. If let's say the pipe that you are going to use, okay, hello, I just want to make sure, can you all hear me? Because here pop up I got some connection issue with my earphone. Oh, you all can hear me, right? Okay, then never mind, we proceed.
So you muted yourself.
Hello, sir. Sir?
I think Sir's was disconnected. Is it?
Is left the class or what? So be like, I had enough of this shit. Drop the mic and just end the call.
Okay, can you all hear me now? I try to use my own computer, the microphone. Yes, okay, thank you. Okay, then never mind. Okay, we still have another 1 or 2 more slides. Okay, never mind. Let us finish our today lecture. Okay, so now we proceed. Okay, just now I said, because sometimes we may need to install the pipeline to try to transmit the process stream with high temperature. Then, of course, the heat energy will be released out from the pipeline. So in that case, what we need to do is we need to make sure the space, okay, among the pipeline is actually big enough so that the heat energy that releases out, it won't disturb the temperature of other process stream. And it will also try to influence the location and also the orientation of the pipeline that we are going to install in the chemical plant. Okay, so basically these are all the consideration you need to consider in order to come up with a complete and logic piping layout. Okay. Okay, then never mind, we proceed. Okay, you see, this is actually the example how we prepare the piping layout. Okay, if let's say the piping layout is a 3-dimensional diagram, then we call isometric drawing, pipeline isometric drawing. Okay, just now our process flow diagram, the PFD that we prepare is actually flat one. Okay, the PFD that developed by using the simulation software is actually a flat one. Okay, 1D. Okay, 1 dimension. Okay, flat one. But if let's say you want to prepare the pipeline isometric drawing, actually you can use a software in order to develop a 3D, okay, pipeline layout. The software that we can use is this one and also this one, M4 Plant software. Okay, so inside the lecture notes, I try to include the video. So later after this, you can try to click the link, okay, and refer to a YouTube video to see actually how the engineer, they can use a software here to come up with a 3D pipeline isometric drawing. Normally, the pipeline isometric drawing is 3D one. Why? So that later you can try to provide a better visualization, okay, to our stakeholder. Okay, we can show to our investor or customer how actually you are going to connect and link all the unique operation together out. Okay, and also later you can directly to provide the diagram here, okay, to your contractor so that easier for them in order to refer to your design in order to construct the chemical plant. Okay, so done our lecture 2 today. And basically these are the steps that actually we will do and cover under the 3rd step here. Okay. Okay, so far any question? And just now I said, okay, just now I told you actually we can try to compare the process here based on the economic potential EP, right? Okay, how to calculate the EP? I will show you tomorrow in our tomorrow tutorial. Okay, so far this is our lecture 2, and our lecture 2 is actually more on theory. So far, any question before we conclude and end our tutorial today? Uma, do you have any problem? No question, Junhan. Junhan, okay, thank you.
No.
Good. Okay, thank you. Thank you. I know. Okay, thank you. Okay, give you
Bye,
another.
sir.
Yeah, hey, wait me for a while. I got some announcement. I want to make some announcement. Wait,
Sir, I got a question.
your attendance today will be recorded by my Zoom. Okay, and later I will record down, okay, your attendance on behalf of you. And also for tomorrow tutorial, we will conduct by using the online method as usual, okay, 2 o'clock until 4 o'clock. But tomorrow, I might be a bit late. Why? Because tomorrow I have a meeting until 2 o'clock. So I might be only able to join the Zoom or start our tutorial at 2:10. I think 2:10 or 2:15. If let's say I'm late, then you just join the link and wait me for a while. Then, okay, then only we proceed our tutorial. Okay? So any question before we close and end our lecture today? Okay, if no, then I will stop here. Similar, later I will upload the video, okay, to YouTube and share the link with you. So later, if let's say you want to do revision, you can rewatch the video. Okay, so if let's say no question, I will see you online tomorrow around 2:10 or 2:15. Thank you and have a nice day.
Bye, sir.